You are joining us here for Teaching with Tinkercad, Webinar 5. This one is called Getting Started with Code Blocks, which is why we're asking a little bit about computer science as you joined, because that's going to be a big topic of tonight's presentation. Now, before I dive in and get too far in, I'd like to introduce myself. My name is Jason Erdreich. I'm a technology and engineering educator, and I'm teaming up with the Tinkercad and Autodesk team to bring these types of webinars and resources to teachers just like you. And I'm excited to be here again. And I'm joined, as always, by my co-host, Randy, if you want to say hello.
Hi, everyone. I'm Randy Sarafian. I'm on the Tinkercad team, and I also help out with another website called Instructables, and I'm really excited to help out in the chat and answer your questions and help move this along.
Yeah, and I'm also super excited that we're joined by another co-host this evening. We're joined by Christian. I'm going to give him a chance to say hello as well. Christian, you want to say hi?
Hey there, everyone. I'm Christian. I'm a product manager on Tinkercad with a focus on Tinkercad classrooms and the 3 editors. And I believe, we'll learn about the 3 editors, in particular the Code Blocks editor. So I'll talk to you about that and show you some examples in a bit.
Awesome, awesome. So before I hand it over to Christian, because he is going to be talking about code blocks, let's go over a couple things that's super important that we want to chat about. So as I mentioned, we are at our 5th webinar, which is called Getting Started with Code Blocks. But looking ahead, we have a couple things coming up. So on November 30th, we're actually going to be launching a 3D Print Better webinar, but that's going to be through a different series. So we're super excited based on some feedback that we received that we're also going to offer a webinar series called Level Up with Fusion in Secondary Education. So that's going to allow our users that are trying to transition to Fusion to get their own kind of dedicated training series just like this, so we can talk about really exciting topics for that age group and that type of conversation. So that's going to be on November 30th. The link for this webinar is, of course, in our slideshow. And as always, the slideshow will be shared with you after the webinar, along with some follow-up resources. Then looking into the new year, we're of course going to return to teaching the Tinkercad, but the schedule is going to be a little bit different. So stay tuned to our schedule, because we're now going to be offering webinar series through the Fusion 360 webinar and teaching with Tinkercad. And just of course, make sure you stay up to date with the Tinkercad blog so you can see the upcoming events, themes, and of course, ways to join us from week to week. But again, we're going to continue to hold these things on Thursdays right around this time. So just stay tuned, because there's much more to come in the coming weeks. Now, before we get too far into this, we also would love to learn a little bit more about your experience with code blocks. So we're going to launch a poll. This is something that we're super excited to talk about tonight in tonight's webinar theme. So you should be seeing that right about now. And we'd love to just get to know what your experience is with code blocks, if you've ever used it before, things like that. So you should be seeing that. Let us know if you know what we're talking about, if you're just getting started, if you've been using this or working with this in your class. We'd love to get to know that, because that's going to help us kind of curve these conversations and assist as we get through our exciting activities planned for tonight. So I am seeing a number of folks just getting started. That's awesome. We're super excited to share a bunch of great introduction type content and resources with you tonight, but also some folks who want more experience, a handful, maybe a small percentage who've been doing this, but there's more room to grow, which is great. I couldn't agree more. I feel like I learned something new every one of these webinars personally, which is always exciting. And also we see some folks that are excited to see how code blocks could be used in a computer science environment. And if that's the case, you are definitely in the right spot. So that is awesome. So thank you so much, folks, for answering that poll. We're going to use that to kind of cater the conversations as we're going through our conversations for tonight's webinar. So before we dive in, let's just talk about how to participate. As you can see, we have a very active chat, which is fantastic. And we're going to continue to use this throughout the night. Randy, Christian, and I are joined by a bunch of Autodesk team members, as always, and they're going to be working really hard to answer your questions throughout the night, throughout the webinar. But we also have the Q&A section. So we recommend folks drop questions into the Q&A, because as you'll see, the chat moves kind of quick. The Q&A will allow us to make sure we see your questions, have a chance to answer that, and it's also something that everyone can review. And again, a huge thank you, as always, to the Tinkercad team that's joining me tonight so we can answer your questions promptly throughout. We're also going to have our dedicated Q&A session at the end, as always, so there'll be time to ask questions as we kind of conclude all of our content. And again, these slides will be shared with you. So before we get into code blocks, Christian mentioned that there are 3 different kind of applications within Tinkercad, and I want to preview that just so you kind of know what the scope of what you could be designing with in case you are new to Tinkercad. Lately, we've been talking a lot about 3D design. This is what the majority of our webinars have been on thus far. And in the 3D design space, you can essentially combine multiple shapes to really make just about anything in this very intuitive interface. So students can be designing different parts, different models, different 3D worlds. In our previous webinar, we talked all about SimLab, which is an exciting way to simulate real-world physics with your designs. And as a reminder, if you've missed past webinars, you can always check out the recordings on the YouTube channel as well. Another application space that we plan on talking about in the future is called circuits. And this allows you to drag and drop electronic components to build electronic circuits right in this interface and actually simulate what those circuits might do if you were to build them on the table in front of you. You can bring in different types of microcontrollers to program and work with both analog and digital things in this simulated space, which is super cool. And code blocks, I'm not going to talk too much about this because we're super excited to be focusing on that tonight. But as you'll learn, it's a great way for students to apply computer science principles to make really fantastic 3D shapes. And that, of course, is what we're looking to learn tonight. And on that, I'm actually going to stop sharing and hand it over to Christian, who's going to get us started with code blocks.
All right, let me share my screen here. And I'm going to take you guys through a couple projects. And then I have a few extra projects that we'll look at the end. But to get started with code blocks, all you need to do is log into Tinkercad, of course. Then you have this blue create button and I can create a code blocks design type. You can see the other types there that Jason just mentioned. So here's my code blocks editor. You see me loud and clear here?
Yep.
Good. On the left-hand side, you see my blocks panel, and this is going to be the blocks editor here. This is my 3D editor over here. So here's my new one. Okay, there we go. So now if I right click around in here, I can orbit around in the 3D space. If I use my zoom wheel, my mouse wheel, I can zoom in. You can see I zoom in, I see these 3 axes here. This is the X, Y, and Z. X is the red one, Y is the green one, and Z is going up, is the up direction. I'll be referring to these a few times throughout the session here, but let's just get started and I'll show you code blocks 101. Drag a block. There we go. And let's call this is a text block. I just dragged this blue text block out, and I'm going to say, let's call this code blocks. I'm typing in the text code blocks here. So I don't see the 3D object yet. So what I can do to see the 3D object, or the result of my stack of blocks, in this case, 1 block, I can click play, and voila, I get the code blocks here. I like it. I'll just zoom out a little bit. I can resize these back and forth a little bit so you can see how you can work back and forth on these. You can also zoom in and out with the code blocks here. I'll leave them somewhat big so that you can see them. I know that we're a little bit tight on space, so I'll just kind of use the panning. Maybe I'll go a little bit farther out. I'm going to make the height here. So what I can do, once I have the block in the actual blocks workspace here, I can change the parameters of these blocks. So I don't want it to be 10 millimeters tall. These units are in millimeters, by the way. So this text is 10 millimeters tall. And you can see it put it right at that 0, 0, 0, right at where those X, Y, and Z axes intersect. That's called the origin, 0, 0, 0. And so since it's 10 millimeters tall, the text is 5 above and 5 below, because it puts the text right, it's referencing the center of that text when it places it. So I can make this 4, and then if I play it, it's going to be much shorter. But as you can see, it's now going to be, since it's a total of 4 high, it's 2 above and 2 below. So what I can do is, well, I want that text to be on the top of the grid. So what I'll do is I'll come down here to my purple code block. These are to my purple blocks, and I'm looking at a move here. You see this move? I'll drag it right underneath. And what I can do is just snap it underneath, and you'll hear a little snap. So what I want to do is move it up in Z, half of that height. So I'll move it up 2, okay? And I'll play it. You see that? So it created the block, and then it moved it up. I can just play that one more time so you see that. Great. Okay, another thing I can do, this is called a translation. I'm moving it. Another type of translation is scale. So I can bring a scale block and just pop it underneath there. And let's say I want this text to be half the size it is. So I'll put 0.5 in that parameter. Then I'll play it. So it'll create the text, move it up, and then make it smaller by half the size. Make sense? I think it's pretty easy. Okay, we're getting somewhere. Let's go ahead and put a backplate here. Before I do that, let's make the color of this text different. So I can click this swatch and change it to, let's make it orange. Okay, let's play that. Great. Everything's working as expected. I'll get into what this little gray swatch is. This means that we're going to make it a hole, which will cut objects out. So we'll do something like that in the next example. So let's add a back plate. And the shape I'm looking for is a box. I'll go ahead and add this box and I'll make it yellow, and then I'll play it and I'll see where I'm at. So you can kind of see how this works is add a block, play it, see what your results are, and then go ahead and keep modifying it. You can, for this box and for many of the blocks, you have this sort of fly out here where you'll have some parameters you can edit. So for this one, I want this to be like, let's make this pretty big, 150 millimeters by, I don't know, let's say 40. And then I want the height to be, let's go ahead and do 4 for the height, just like the text, but the text we moved up. So the text should be raised above this box. So let's play it and see what happens. Okay, now I have a pretty big box back there. All right. That might be too big. So what I might, make this smaller, that kind of thing. Maybe I'll make this 20 and 70 and 20 and then play it. And you can see that I get something that looks more like this. And I can keep iterating here. Let's make this 90 and so on and so forth, that kind of thing. Well, that's great. So, but what happens when I go and change the name? Then the box doesn't fit, right? So let's just call this new text. Let's just call this something text like this and play it. So now I have text, but this box is too big. Well, we have some handy new sizing blocks that will help us resize this. So I'm going to show you how this works. If I move down here, let me go ahead and put this back to code blocks. Okay. And I'll just play that. Great. One thing you can do is speed up the way it plays back. I kind of leave it on this sort of average size so you guys can see how this is playing out and what's happening. But we may speed that up later. So I want to make this box always fit the text. Okay, so we're building an auto sizing name tag. This name tag will always look great no matter what text you put in there. It's all based off the text. So this box needs to resize itself based on what the text we've entered in there. So I can come down to these purple blocks, these oval blocks. This one says size. And I'm going to say, I want this size, the width of this box to be the size in that x-axis. So what the size block does is it looks at the previous created object, which in this case is the text. And it's going to look at the size in the x. And then it's going to say, it's going to put that number in itself, and then you can use that later. So for this box, it's now when I play this, it's going to be the exact width of that text. Watch this. Great. Let's do the same for the length of this box. So I'll go ahead and what I can do is right click on that size block, duplicate, and it follows my cursor. I can put that right in there, but I don't want the x-axis. I want the y-axis, which is going to be this green axis, the height of the block. So I'll say y. And now play. Great. Awesome. So it's totally fitting it perfectly. Now, no matter what I put in here, I could just put in my initials, right? And it will perfectly fit. You see that? Great. This is what I want. And this is the start of my auto sizing name tag. I'll put it back to code blocks, play it, and everything's working as expected. Good. Now, I don't want it to fit so tightly. So what I want to do is do some math. And this is very easy. Don't get intimidated by math. It's very simple. And this is a good one maybe to show your students. I'm grabbing this one with the 2 circles on each side and an operator in the middle. I want it to be this size, but I want to add a certain padding. So I can say, let's put 5. Okay. So I have the size of the text plus 5 in the width. And I'm going to do the same here. So let's do this. I'm going to drag that out, put this one in here, and make it 5. So I can have that length be that. Okay, good. So that's the size of the box. I could also do the height. If in case my height changes, I could say the size. I can come back and grab a size block and put it in here. But I want the z-axis for this because that's the up direction, right? Okay, let's test this all out and see what happens. Great. Everything's good. So now I have a little bit of space around my text. So you can see the power of this size block. Just think of it like this. The size block and its sort of companion position block are always looking up the stream to that last blue block or whatever object was created last. Now I'm going to show you a trick where you can store that in a variable in case it's not just the very last object. Okay, so let's move on. What I want to do for this particular name tag is have a little space. I want to have a little circle at the end here with a hole cut out of it. So what I'm going to do is use a scale XYZ. Now you saw the previous scale, which scaled the object perfectly in all directions. The scale XYZ is a little more versatile. You can scale in one direction or many. So let's just go in X. X is again the length of this text. So I'm going to say I want to scale it just a tiny bit more in X. And I'm going to leave it at 1. 1 will not do anything. It'll just scale it by the same size. But the trick here is I want it to scale from the right-hand side, meaning right where this edge is here. I don't want that edge to move. So what I'll say is scale 1.1 from, and what I'm going to do in this case is use the position block, which again looks at the previous object. And in this case, I need to say custom point. Okay. I hope you can see this. And we're going to give you this example later, but I'm going to scale from a custom point in X. And it's going to be the position X max. And let me just explain this a little bit. So just like that size block I used, it looked back at the previous object, which is the text, and grabbed that size. In this case, it's grabbing the position of this of the block. In this case, because it's the last blue block, it's getting that max X location, and then it's going to use that as the scale point by which it scales. So watch, if I play this, you'll see that it will scale it from that. You saw how this edge didn't move. It made this jut out a little bit. So we can adjust this. You know, if we want it to be 1.05, maybe that's a little better. We don't need that much space there. Great. Okay, so that's the scale XYZ block. Very handy. That's a new one for us. So now I want to, what I want to do is put a cylinder at the end of it. And hopefully I'm doing okay on time here. Let me know if I'm running a little late, but I'm going to keep going here. So I'm going to put the cylinder in here and play that. And you can see this cylinder is not the right size. So I'm going to use my handy size block. And so what I can do is I want to make this the same sort of length here and the same height. But if you look up here, it won't grab the quite the right size. It won't grab what am I saying? If I put the position block down here, let me just go ahead and build this. So if I move it and I put the position block in here, I want to move it in the X. It's going to grab that cylinder's position. I want it to grab this back plate's position. So what I'll do is set a variable after that back plate gets created. Hopefully this is not going too crazy for you. So what I'll do is I'll create a variable here. Okay. I'll create a variable and call this X max plate. X min plate. Since it's on the left-hand side of that. Great. And I'm going to set this variable right after I created that box, which I'm using as my plate. So I'm going to say set my variable X min plate to, I'm going to use this position block, X axis min. Okay. Good. So I'm storing that, and I can use that wherever I want downstream now. No matter what object came before it, it's stored in there and I know what it is. So I'm going to move this now to that variable. So here's my X min plate, and I'm going to grab that. I've set it already upstream and I'm putting it into the move X. And now watch what happens. It's going to move it out there. Great. Now I just need that radius to be the right size. So I'm going to set that to, since I need it to be the same size as the block, I can just put in a size block there. And I'll go ahead and just drop that in so that it's the right radius. One thing I will say is it's a radius. So again, I'm going to use a math block here. So I want to divide that total length by 2. And again, I'm going to give you this later, so you can pick this apart later. But basically, I want to, since I'm entering a radius, I want to divide that total length by 2, so that when I get this, it will fit. Divided by 2. I picked the wrong one, so I'm going to let's see, I want this to be y-axis, not x-axis. Look at that, it made it too big. So the y-axis is the height of the block of the text. I made it the width of the text. That's why it got so big. Okay, so we're good. And the height, I'll go ahead and just enter, I think we're working with 4 here, so that should be good. Let's see. Excellent. It's a little tall, so I want this to be the size in the z-axis. So I'll use my handy size block and make sure that this says z. So I'm matching that block. Okay, let's play this and see where we're at. There we go. See, now this is looking really nice. And I want, now I only have a couple more steps here, so bear with me. I'm going to right click on this cylinder and duplicate. Now I have 2 of the same things happening, but I want this to be a smaller hole that gets cut out. So I'll say this is a hole. Also, I'm going to get rid of this green math block with the size in it. And I'm just going to say I want this to be a radius of 4. Okay, so let's play that and see where it brings us. And I promise you we're almost to the end here. And then we'll kind of see how our code works. Great, so everything's in place. Now I just need a group. And you can see this group, what grouping does is that if you have holes in your, hole shapes in your recipe here, it will cut them out. So watch me play this through. And one more time through. Great. And of course, I can make this cylinder be the same color as the back plate. And what I'm going to do is just speed it up by clicking the speed to all the way to the right, then playing it, and it will play back a lot faster. And you can see there's my finished name tag. Now, the beauty of this and why I led you through this whole thing is that you can type whatever you want in up here, and it will, using those position and size blocks, it always fits. Okay, I can add a little more space there on my scale XYZ if I like, but you get the idea. All right, so this project is linked in the deck that you guys will get with this. How are we on time? Can I go through the vase now?
You're definitely doing well. I think we can go through the vase, and I think as you covered all these awesome fundamental things, we can also dive to the really fun stuff too.
Yeah, okay. Let's do that. So I'm gonna go ahead and show you a vase, an easy way. I did this with my daughter's 3rd grade class and my son's 4th grade class, and it was quite easy, and they loved it. So I will show you how to build this, and I'll be a little quicker on this one. But I'm going to create a new code blocks here, and I'm going to drag out a cone shape here, expand that cone shape, and I'm going to just put in some new numbers here. I'll call this 20 for the top radius, 20 for the bottom radius, and then I'll call height 2. So I'm making a very short, let's say a 6-sided shape. So let's look at what that's what we get. Okay, so this will be the shape of our vase. This is one layer. I'll change the color to something a little easier to see. Do this. Now, what I want to do is I'll move this up so it's sitting on the grid. I made it a height of 2, so I'll move it up 1 so it sits right on top. Again, Z is up, so I'll put it in 1, and so it'll create that and move it up. Great. Now I want to add a shape to cut it out. So I'll use a cylinder, and this is going to be where the flowers go into the vase. Okay, so let's do this. I don't want it to be a solid hole. I want it to be a hole. Remember, I used a cylinder to create the name tag hole. I'm going to use the cylinder to create a hole here again. And in this case, I want this radius to be 15. Let's see. I'm just looking at some of my notes here. I want the height to be 2. Sides could be, let's just make it 15 or so and play it. And so we should have that come in. And yes, it's there. You can't quite see it because I haven't grouped it yet. So let's group it. Again, let's see. I'm going to move it up. Let's move this up in 1. Move this up 1 in Z. Play that. There, now we see it on both sides. So when we group it, we get the whole. Check this out. So this is going to be great. Okay, this is going to be the basis for my vase. Okay, so I want to do this over and over and over. So how do I do that? Well, in coding, we have something called a loop. So this is a repeat block that I'm going to drag out, and I want to do this, let's just say 25 times. Okay, I'm going to basically find my copy. I'm going to copy whatever was just above it. So I'm going to do this 25 times, copy it, move it, and rotate it. Let's do a rotate. So let's enter some parameters here. Copy's fine. Move, I want to move it up 1.5 because it's too high, that element. So I'll move it up 1.5. So it's slightly overlapping. I get the right there. Yes. And I'm going to rotate about the Z-axis since that's the up direction. So it's going to spin around its axis, and I'll get like kind of a twirling effect. And I'll change the axis by 5 every time I create that new one. Okay. Now my pivot, I can leave this at 0. I can leave it at 0. I like to put this in there in case I want to try spinning something. So let's see what this gets us. It's going to create that base layer, then it's going to duplicate it, and I'm going to make this go a little faster so that we can see the result. And now you can see we have our rotating effect on this base. That's kind of fun, right? I can add a bottom by just putting in one of these guys here at the bottom. And that will be at the end. And we'll call this same color, that color. And maybe this has to be top radius of 20 and a bottom radius of 20. So I'm seeing some emojis. Thank you for the emoji applause. I really do appreciate that. I'll just make that. There's more. Thank you. So that means you're liking this. Very good. Okay, so we got that. Now I want to show you some. So this is a repeat block. Now check out what I can do with this. There's something. You saw how I had like this rotate in here. What if I just put 5 in here? So it's going to rotate about the x equals 5, meaning it's not going to be exactly on that origin rotating about, and we get a different effect. And I'm going to just bump this up, this repeat to like 30. Oh, 30. Now watch the effect I get. Now it's kind of off center, rotating around. That's interesting. What if I added a scale in here? Let's do a scale. So a scale from center. I'm going to use the scale XYZ in here. And check this out. So every time it goes through, I'm going to scale the X and Y, which is just that how it sits on the table. It's not the height. I'm going to scale that by 0.98. So it's going to get incrementally smaller and smaller. Okay? Now watch this. When I play this, you see how it's getting smaller and smaller as it goes up? And sometimes when code blocks freezes like that, you just have to let it think a little bit. It'll keep working. Now that's interesting, but maybe I could change this rotate angle by a little bit more. I'm going to make it 15. And this will maybe really accentuate that offset rotation and gives me that sort of like a corkscrew effect. Kind of looks like a horn now, a little bit. So yeah, I mean, you can look closely at the pattern. You can tell CodeBlocks is thinking at the moment. And again, just let it run if it gets hung up. But you can see that now these shapes are all staying the same size in Z. They're the same thickness. But as they get higher, they're getting smaller in X and Y. So that's the nice thing about the scale XYZ. And I'm just doing it about the center. Okay. One nice thing you can do is turn this into orthographic view to make sure you can still put a flower in there. And you can still see the bottom there. That's fine. So that's the idea. Now I'll put this back. This is not really a easily 3D printable vase. So one thing you might do is I'll put this back so it's just going straight up and down. And maybe just rotating this by about 10. And I can play that. Now check this out. These are, let me go back to my perspective view here.
Christian, we have a question from the chat that I don't know the answer to, but they're asking why did you use a cone shape instead of like a cylinder or polygon?
I'm going to show you that right now. And the reason is, if you look at this, if you're going to 3D print this, you'd have all these overhangs wherever you see this hanging over. Well, one thing I wanted to do was make it so that it doesn't have the overhangs. Instead, it creates sort of a gradual ramp, right? So what I can do is come up to this top cone and I can change this. So how did I do this? I'm going to refer to my notes. But basically, I make the bottom radius smaller than the top radius. So watch this. I'm going to make this 18 and then watch what happens to these overhangs. They're gone. So it's going to print on the previous layer and then work its way out. Cool. Also, another reason I use that cone shape is it has a lot of these parameters in here. You can change this. If I want it to be 8 sides, I just change that to 8. And now I have an octagonal vase. Okay. And again, I don't have overhangs. So actually, I was playing with this today and learned that, you know, some of these you can just keep playing with the numbers and find new ways to design things. And there's really no way to know what it's going to do until you play it in the code blocks editor. So that's really fun to discover. Okay, so that's enough on that one. One thing I will do is show you that you can edit these in the 3D editor. Okay, so there it's just finished. This would print if you have a big enough, tall enough printer for this, but what I want to do is now bring this into the 3D editor. So let's go to export. And I'm going to click shape. Now shape will allow me to bring this into the actual 3D editor that we saw at the beginning of the webinar. And here I'm publishing the shape. I actually did this earlier, so I won't, it does take for something complex, it does take maybe 2 to 3 minutes, and I won't waste anyone's time here. So I'll just sort of show you an example. You give it a name, a description, vase made in code blocks. You get the idea. And tags if you want to be able to search it out later. And then you click Save Shape. I'm not going to do it right now because I have one that I created and I'm going to show you that. So I'll click this Tinkercad logo to go back. So I have here's the 3D editor. And you'll find those shapes that you save in your creations up here in the shapes library. Okay, so you just click this in the shapes panel, you click that drop down and you'll have categories and you choose your creations. And here is a vase that I created earlier. Great. Here's a rose that I found in the gallery and it's much bigger than the vase. So what I might do is scale that down. I'm going to click this handle, press Shift and scale it down. Press F to zoom in and put that right inside. And you kind of get the idea. So yeah, I mean, we have a little bit of self-intersection here, but that's the idea. You can bring those code blocks designs in here and use those within the 3D editor. And of course, you can go ahead and group any objects with this, cut more objects out of that shape, that kind of thing. Okay, so that's that workflow. And now I just want to show you a couple extras that we're going to share with you in the PowerPoint. By the way, here's that rose made by Eagle in Flight. Thank you, Eagle in Flight, wherever you may be. This one is a random sized icicle. So I'm using that position block I showed you to find the position of the last icicle I create. So I'll walk you through this just real quick. I'm creating a line of 10 icicles, and I'm using this cone shape again, which is my favorite shape, by the way. I'm using a top radius of random. So I'm creating a randomly sized top of the icicle and random number of sides. This random block is really cool. It's right down here in the math block, so you'll find it down here. But basically, whenever I play it, I get a new result. You see that I'm using that, I'm moving it to what a variable I have defined called next position, and then setting that next position to the x-axis in that line. So it's the extent, the max in the x, and then I'm just continually adding icicles to it. So let's play that and just see. I think it's just easier to understand if you look at it. So within this repeat block, I'm continually setting my variable for the extent of that x position in max, and then I'm moving the next one there, and then setting it again, and just keep going and going. So if I look at this, no matter what I do, I have a random set of icicles. These are all different sizes, and they're always going to be perfectly in a line. So that, that position block is very handy when you're building objects and they need, they become complex objects and they need to sit on top of something, or you need to stack it. You can use that position block, set it as in a variable, and then use it later. And it's very handy in this loop right here, for example. Okay. Another one that I created is, okay, here we go. Let me refresh. Thanks for the emojis, folks. Appreciate it. This one is a lot more complex, and I'm not going to go through it too much, but when I play it, you'll kind of see what it does. And I'm going to speed this up because it's very, here I'm making a random set. Here I'm making a forest. Okay. So let me expand this. Now, every time I play this, I get a new randomized trees and randomized locations. And it's very fun. So you think about building levels or environments for the things that your students are creating. I will just quickly finish this. What I want to point a few things out in here. Okay. So here you only see these blocks. It's creating a template of a tree, and then it's moving it to a random location. Okay, that's all you are seeing here. All of the secret sauce is in these templates. So you can create templates which contain functions. And this is sort of introducing people to, coding ideas. Functions carry out a set of instructions. Okay. You can create a template down here, very much like you create a variable. You can see I've had several variables in this, but in this template, I have it compacted down so I can expand it. Okay, so here's what's going on inside. And here I'm creating branches. I won't get into the details, but basically I'm creating a random set of branches. I think it goes from 1 cone to 5 cones, and I'm making them scrunch up together and be green like branches do. So I'll go ahead and collapse that. And then I'll bring up this template, which actually calls the branches template. So this is the tree template. And if I expand this, you can see I'm calling that branches down here. So I'm creating the trunk. You can see, just look at some of these purple blocks. You can see I'm using that position a lot. I'm using a lot of random. And again, you'll get the links to this, so you can go break it, pick it apart, do whatever you want to it. But it's creating that branches. It's creating that branches within this template. Okay, so I'll collapse that. So I have my branches. I have my tree template, which calls the branches. And then here, I'm just creating 20 of them by calling that tree, create tree templates. So here I can just drag this out and it will create a tree, one of those randomized trees. I'm putting that inside a random block or in a repeat block and creating a whole forest. And no tree is the same. So the power of code blocks, you don't have to, you really give it some thought as to, computational thinking, how you might build stuff with the blocks you're given and setting variables and templates and then using those wisely. And really, you spend a lot more time thinking about that. But then once you build it, like my name tag, I don't have to rebuild that name tag ever again. I can just put somebody's name in there and it builds it. And so I can do that for 30 students in my class, and I can 3D print them, and I don't have to rebuild the same thing every time. Or you put that challenge to your students and have them build it. So I think that's it. I think you've heard me talk enough. How are we doing?
We're doing great, Christian, and that was absolutely fantastic. And we had a ton of really fantastic questions in the chat that I'd love to just take a minute to recap and kind of highlight a few things. But huge thank you from all of us, because that was awesome. I think this was a first experience for many of our attendees, and I think everyone's super excited to see how code blocks can be used in Tinkercad. So really fantastic, and thanks so much for sharing. Lots of emojis. I don't think I've gotten this many emojis personally in any of the past webinars. So you've definitely you've taken over and you've won the emoji wars. Not that I knew that was a thing.
Thank you. That really means you were listening and you enjoyed what I had to share with you today. Thank you so much.
Awesome. So I'm going to take over the screen here. And then before we dive into our Q&A, we're not just saying goodnight just yet. A bunch of folks were asking, hey, how do I go back? How do we review that? So I want to highlight a couple super important things. So first and foremost, every webinar is recorded and we publish them to our YouTube channel. So sometime tomorrow, you'll be able to go back and rewatch this at your own pace, pause things, everything like that. So stay tuned. We're going to follow up. And we did also drop the link to that in the chat already if you want to go back and see our past webinars. But this is the slideshow that we're also going to send out. And every single project that was highlighted tonight has its own slide. So you can see a recap of it, as well as links to the actual designs that we used, including the vase projects, including how to bring things into your 3D designs, as well as even the icicles and trees. So as we said, you can open up these public designs, make a copy of them, really look at each block, manipulate it, get hands-on with it, so that way you can go back and tinker with these things and get to experience it after tonight. So all this is going to be shared with our attendees, and also again recapped on YouTube. And I think the big thing I want to highlight here, because I think so much was already said, is just that this brings in the conversations of automation. A couple webinars ago, we talked about the duplicate tool and how we can use it to make patterns, right? You can use code blocks to make random patterns. Say that your students are designing something and they want these random shapes to be more like nature or more like whatever it might be. You can kind of be using 3D design and code blocks at the same time in the same space, yet covering so many real world skills and different types of learning environments. So it's very exciting that you can do all this within the Tinkercad ecosystem, which is why we're super excited that we got to talk about that tonight. And thank you again for attending tonight, because for all of our folks that attended live, we're also going to be following up with a PD certificate, professional development certificate for your 1 hour PD, along with these slides and all the great resources and things like that. And folks were also asking about, how do you learn more? How do you get students started with these things? Where do you find tutorials? We dropped a bunch of links for those, but the first place I would go is the Tinkercad Learning Center and the Tinkercad blog, which is linked throughout the slideshow and everything like that, but also through some of our really exciting competitions and events that are happening. So I'm going to bring Randy on to tell you about some exciting challenges for your students.
So yes, first off, I kind of teased this in the last webinar, but challenges now have their own page. So you no longer have to go to the blog. It's no longer a little confusing. There's a page. You can find it right on the Tinkercad site. It's dedicated to challenges. So we currently have 3 challenges running. Nuts and Bolts Challenge, which is encouraging students to design objects that can be attached together with a nut and bolt, which is a little bit of a challenge if you've never done that before. We have a SimLab challenge where we're feeding the fish, which is one we saw last week. And I kind of alluded to, you might see that again. So you could go try out the Feed the Fish challenge designed by our very own Jason. And there's a Holiday Feast challenge, which is designing for a quarter scale table and putting your favorite holiday dishes onto the table in spirit of the holiday season that's coming up. And for those who are here tonight and are super excited about code blocks, before we move on, I just want to mention that we will be having a code blocks challenge, which is going to line up perfectly for our hour of code. If you do that in your classroom, that's a challenge you should check out. And I could tease to the people who attended that the challenge that will be upcoming is a 1 shape challenge where you use a single shape to design things seen in nature, such as the icicles or the trees or the snowflake generator that Nicole shared in the chat. So I highly encourage you to check that out. In about a week or 2, we're launching that. And we also have contests on Instructables, and there are ones specific to Tinkercad and Fusion if you're with older or more advanced students. We have the robotics contest, which is always a fun one. We have jewelry, which is another one with especially a Tinkercad prize. And we have the Make Some Noise, which is basically anything that makes noise. It could be an instrument, it could be a stereo, it could be just something that's really noisy. So I encourage you to check that out. And then we have one for educators, the project-based learning contest, where you can share how to use Tinkercad in the classroom or just general project-based learning content.
Awesome. And on that, I just want to also remind folks what our next webinar is going to be. It's going to be in a slightly different place. It's in our Level Up with Fusion in the secondary education webinar series that you can join same place or same day and same time. And we're going to be talking about 3D printing better. So tips for effective 3D design, how to take advantage of Fusion 360's features for actually preparing G-code and connecting to your 3D printer, and just lots of really great strategies for taking your designs into the physical world. So that's something to look forward to. And before we say goodbye or dive directly into our Q&A, I want to say again, thank you for all of you for attending. We hope that you, of course, enjoyed webinar number 5. We're super excited that we got to talk about code blocks, which I think is one of our favorite things to talk about and use. And I also want to say, again, thank you to the whole Tinkercad team that's been with us tonight, answering your questions in the chat, dropping the links, and all those things. So again, we'll be following up soon with different resources and things like that. So thank you again. We hope you enjoyed it.